Okay, today we're going to learn about multiplying binomials and other polynomials. Let's start by multiplying two binomials together. Okay, so our first step is to take the first term in the first binomial and multiply it times the first term in the second binomial. 3a times a is going to give me 3a squared. Then I'm going to multiply the same 3a by the outside term, 3. 3a times 3 is 9a. Then I'm going to multiply the second term, 2b, times a, which gives me 2ab. Notice I wrote them in alphabetical order, a and then b. And then 2b times 3 is going to give me 6b. We don't have any like terms here, so we are done. Once again, we're going to be multiplying two binomials together. We're going to again take the first term, 2a, and multiply it times 5a, which is going to give us 10a squared. Then we're going to take the 2a and multiply it times 2, which is going to give us 4a. Multiply the 3 times the 5a, which gives us 15a. And then 3 times 2, which gives us 6. We're going to then combine our like terms. So we're going to get 10a squared plus, 19a plus 6. 4a plus 15a is 19a plus 6. This time we're going to multiply a binomial times a trinomial. It really isn't all that different. We're going to take the first term in the binomial, and then we're going to multiply it times the first term in the trinomial. 2a times 5a squared is 10a cubed. 2a times 3a is going to give me 6a squared. And then 2a times negative 5 is going to give me negative 10a. Now we're going to move to the second term, the 3, and multiply it times each of the positions. Notice we're going to multiply 3 times 5a squared. So what I'm going to do is I'm going to put it right under the 15a squared, right under the 6a squared. So when it comes time to combine like terms, they're already together, one under the other. Multiply 3 times 3a, and I'm going to get a positive 9a. And then 3 times negative 3 times negative 5, which is going to give me negative 15. And then I combine my like terms. I get 10a cubed plus 21a squared minus a minus 15. By lining up the a squared and a terms together, it's easy for me to see my like terms in order to combine them. Now this one's a special product. These are called conjugates, and we're going to multiply the first term times the second one. They're called conjugates because they look exactly the same, except that the operation in the middle is the opposite. So we're going to multiply a times a, which is going to give me my a squared. And then I'm going to multiply the a times the positive b, which gives me positive ab. Then I'm going to multiply b times a, which gives me negative ab, because I have a negative b times a positive a. Then I'm going to multiply negative b times a positive b, which gives me negative b squared. Notice what happens with the middle terms. The middle terms, one's a positive AB and one's a minus AB, so they're going to cancel out, leaving us with a squared minus b squared. This is a special type of binomial. It's called the difference of two squares because it's subtracting, which means difference, and both the first and the last term are perfect squares. This will be very important when we get to factoring in the next lesson. Here's another example of two conjugates being multiplied together. Notice they have the exact terms except the operation in the middle is opposite. One's a positive, one's a negative. Again, these are called conjugates. So we multiply 2a times 2a, and we get 4a squared. Then we multiply the outside term, 2a times negative 3b, and we notice we have a 3b times 2a. Those terms will cancel out. So instead of having to write them down and then scratch them out, we would know when we multiply conjugates that our middle terms will cancel each other out. So we're left with 3b times negative 3b, which is 9b squared. Again, this is called the difference of two squares. Because 4a squared minus 9b squared has a difference between two perfect squares. This is another special type of binomial multiplication. This is called a binomial squared. A plus b times a plus b. Basically, it's a plus b squared. So we're going to multiply a times a, which is going to give me a squared. The back part, of course, is b times b, which is b squared. And then if you notice, the middle term is a times b and b times a. That simply gives us two ab's, and that goes into the middle. This gives us the result, which is called a perfect square trinomial, because you can separate this into two binomials that are exactly the same. Here's an example with a minus sign in the middle. 2a minus 5 times 2a minus 5. We multiply 2a times 2a, we get 4a squared. In the back, we're going to get a positive 25, because a negative times a negative is a positive. Notice when we multiply binomial squared, the first and the last terms are always positive. Now we're going to combine the 2a times negative 5, which is negative 10a, and then negative 5 times 2a, which is another negative 10a. So we have two negative 10a's, which gives us negative 20a, not negative 10, but negative 20a in the middle. Sorry about that. Again, this is a perfect square trinomial. Well, that's all my examples for today. We'll see you in class tomorrow, and you'll have a worksheet on multiplying polynomials together. See you then.